So in 5-3, we are officially moving on.
Math makes me cry.
So what did we learn in 5-1? Let's recap what we've done so far.
Triangles.
I don't.
Triangles. What about triangles?
Oh, like the different types.
The different types. So we talked about isosceles. We talked about equilateral. We talked about acute. We talked about scalene, obtuse, and right. Anything else we talked about before we went to
Right.
Then we went to congruent polygons. So you were looking at using the notation of the different. Josh, go to your seat.
No, they're not even here.
The different. I can't even think because you guys are all talking. The different angle and side markings for figuring out what pieces are congruent to what, and so on. Okay. So. In 5-3, we're going to really dive into equilateral and isosceles because these are the most we can do things with because they're special. That's only for right triangles. But I like your enthusiasm.
Miss Amy, can we just review?
We just did. That's what we just did for the last
count, bro.
2 minutes.
Still 2 minutes is not. I was just
okay. So
2 minutes goes for like 2 weeks, bro.
Josh, go to your seat. You're distracting me.
I don't even focus there, bro.
Too bad. Go.
I can't focus when you're here, bro.
All right. So our learning target says I can use the base angles theorem and the isosceles and equilateral triangles to find different pieces of information.
We did not review for 2 minutes because the videos have only been going for a minute and 45
Oh
seconds.
my
YouTube
goodness.
videos?
All right.
That actually helps me.
So, in this picture at the top, it says we've got a triangle here that's going to be an isosceles triangle because we know we have 2 legs that are the same length.
Wait, what page is this?
And then we start looking at some other things. So, the ones that are on the opposite of the same legs or that are on the base are called the base angles. The one angle that's different than the rest is our vertex angle. And then over here it just says we have to keep in mind that equilateral triangles have to all have equal sides. So that's the special part of those. And they would all be 60, 60, 60 angles.
Wait, what?
All right. So the first theorem we have there is the base angles theorem. Base angles theorem says if 2 sides of a triangle are congruent, then the angles opposite them are also congruent. Which makes some sense, right? If we have a side that's produced by an angle, and we have another side that's the same length, the other angle has to be the same to have produced that side length. Okay? So it's saying if these 2 sides are the same, the angles opposite them are the same. So which angles would that be?
C and D.
This one would be C, and this one would be B. So we would already be able to say that those 2 angles were congruent. Okay? The converse to that, what did converse mean again?
Opposite.
We flip the if and the then. So now we're saying if we know 2 angles of a triangle are congruent, then the sides opposite them are congruent. So which 2 sides are congruent if we know these 2 angles?
B and A.
We need 2 letters to name a side.
C and A and B.
CA and BA. The 2 sides opposite those angles. Okay. Example 1 says, name the legs of the triangle. We're talking about this one right here. So what are the legs of this one? We're going to have a base and we're going to have legs.
Angles. Angles.
Woo, whoa, hang on.
Base
Connor,
angles.
what are the legs?
Base angles.
Shut up. F-E.
Base angles.
F-E is the base.
Base angles.
Okay.
Oh, the legs.
If you had listened to Connor, he was on to the right track for
Base
us.
angles.
The legs are the 2 that are the same. So that would be DF and DE. Knowing these 2 legs are the same length, which 2 angles would be congruent?
E and F.
E and F, the 2 angles opposite those sides. So angle, I'll try to stick with what I went here. Angle E and angle F. Okay? What is the vertex angle then?
Angle
D.
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 angle D up here, because that one's different than the other two. And then the base would be
No, FE.
the side opposite that vertex angle, which is this one down here. So you can call it EF or you can call it FE, doesn't matter.
Yo, this is easy. What the heck?
Good. Alright, so then let's think about this one. It says if the measure of angle F is 72, then we have to find E and D. These are hard to do for me without actually labeling what I know on the picture. So I'm going to go back and do that. If I know F is 72, that means this angle is 72.
Oh, so E 72. And then that means G.
Okay, so then we know E is the same because we said those were congruent.
You're smart. What the heck?
And they need to equal 180. So 180 minus 72 is 144. So what do we get for an answer?
19.
36. Which makes D 36 degrees. Hey! There's a bit more going on in example 2 because we've got a triangle inside of a triangle and one big triangle. Yes, this is where it starts to become geometry. This is the fun stuff. Alright, so it says, if angle NKM is congruent to angle NMK, then what else do we know is congruent? So let's label these. Angle NKM would be this angle here, is congruent to angle NMK. Okay, we know those two angles are congruent. So what else must be congruent?
Are you okay?
So ignore this part. We're not using that part right now.
M and N.
I don't know why it's so dark today. Okay, so what we know right now is this would be like the triangle we're talking about, MKN, and these two angles are the same. So when we know two angles are the same, we know the sides opposite those angles are the same. So which sides would that be?
M and K.
MN would be the side opposite angle K. And what other side?
K and L.
KN. Correct. This side here. So we know MN is congruent to KN.
Wait, what's a test?
Not what we're talking about. Okay, now we have different information that says if LN is congruent to, is that, I don't remember what it said. MN. I just slid down when I got up. So if LN is congruent to LM, what else do we now know is congruent?
N and ML.
Alright, let's label first. Let's not just shout random things out because that stresses me out. Alright, LN is this line here.
L.
We're saying that line's congruent to LM, which is this line here.
No. No. It should have been
Oh, LN, shoot. LM. Okay, ignore this line. So now that we know these two lines are the same, what do we know is the same else?
LJ. LJ.
N L
LJ
and N K.
and MLN.
N L and N K.
LJ is LN.
We're looking for angles.
Angle.
Remember, if two sides are the same, the two angles opposite them are the same.
Oh, so LM or ML.
Okay.
ML, MN.
Wait,
Angle M.
okay, angle M and what?
M.
Angle M.
N. MN.
Which part of N? This side, the whole thing, this little piece?
What do you mean, what?
Go back to algebra.
J.
What does that even
No, angle K.
What? What?
Okay, angle N could be 3 or 4 different angles if we don't give it 3 letters.
Why is there a highlighted
L, N,
L, N, M.
LN and M.
L, M, and
Woo! All right, L, N, M. Because we're only talking about this side of angle N. So these two angles are also the same now. Okay. You can only use one letter if there's no other angle created at that letter. If there's more than one angle there, we can't just call it N, because that could just be anything you wanted it to be.
Exactly. So that I'm right.
Alright, so go ahead then and flip the page, because that was painful. Woo boy!
I think it only gets worse.
We're getting off to a slow start here, friends. Alright. So, at the top, we've got some corollaries. Corollary 5.2 is the corollary to the base angle theorem. It says, if a triangle is equilateral, then it's also equiangular. That makes sense, right? If all three sides are the same, all three angles have to be the same. Because if we said two angles made two equal sides, then three would still have to be three. Okay? And then our corollary to the converse of that theorem says, if a triangle is equiangular, then it's also equilateral. So now we're saying if every angle is 60 degrees, all three sides have to be the same length. Right? Alright, good. That part shouldn't be rocket science for us yet. In example 3, it says, find the length of ST and SU. Then identify the measure of each angle.
Oh, 60, yeah.
So how do we figure out how long ST and SU are? They're all 5. Why?
The angles are all the same.
Because they were equiangular. So that's that corollary we just talked about. So all of them are now 5.
Oh, I didn't see. I thought that was another S.
No, it's a 5. It's just kind of blurry because I made the picture really big. Okay, then each angle was what?
5.
60. Each angle would be 60 degrees.
It makes so much sense. What y'all talking about?
Well,
If we had to split 180 into 3 equal pieces, each one would have to be 60. Right?
Yes.
Oh, yeah.
Okay. Example 4 says, find the values of x and y in the diagram. I'm going to turn you loose and see what you guys come up with.
So why is 3?
So talk to your table, see if you can come up with them, and show how you got your numbers. Alright, I tried to explain my reasoning in my picture, but it's kind of hard after the fact for me to explain it. So,
I was right.
I found y first because that was an equiangular equilateral triangle. So all of those 4 sides are 4.
I get why it would be good, but I don't
Then,
think it would be.
we had to use the idea that in our next triangle, if these 2 angles are the same, then the sides opposite them are also the same. So that's my red marking, so you can kind of hardly see this. But if this one was already 4, because it's part of the other triangle, then it still needs to be 4 over here.
So 3.
And we had to solve for it by setting x plus 1 equal to 4, which gave us 3.
It actually makes sense. What the heck?
Okay?
That makes sense.
So it's just reading your picture and making sure you understand what your markings are.
It's just adding 1 to S and making it 2.
Alright, see if you can do number 5 now. Oop, my work. Alright, we knew that this was a 60-60-60 triangle. Then, I used this idea that said this corner here was 90. Because I knew it was 90, I could do 90 minus the 60 to figure out that angle was 30. Then, I ignored this triangle completely. And I said, well, if these 2 sides are congruent, the converse to the base angles theorem said that those angles need to be the same. So those were both 30. But it wasn't asking for those, it was asking for this one. So I did 180 minus the 2 I know, which got me to 120.
That makes sense, yeah. I just didn't know you were doing this.
I looked at it and I said, that looks like it spit 60-30. And that was my reason.
Alright,
I didn't realize.
that is it for our notes.